let's look how we're going to solve this rational equation. Again, we want to make sure that we find our LCM so we can clear out all the denominators. Our first denominator does factor. It's a difference of perfect squares, x minus 3, x plus 3. Our second denominator, x squared, could be rewritten as x times x. And our last denominator, if we recall the first rule in factoring is always look for something common, is x times x minus 3. So those are our multiples. Now we need to look to see what's common. Common to all the denominators is nothing. But then we can go back and find something that's common to some of the denominators. This x minus 3 is common to 2 of the denominators. And then we also notice that there is an x common to 2 of the denominators. And then we look to see there's nothing else common. So everything else is what we're calling a leftover. So we have this x that has not yet been accounted for, as well as this x plus 3. So our LCM has 4 factors in it. And we're going to multiply each term in the original equation by all 4 factors. Now we're multiplying by this LCM so that we can reduce and clear out our denominators. So we can reduce x goes into x once and x minus 3 goes into x minus 3 once. X times x goes into x times x once. And x minus 3 times x plus 3 goes into x minus 3 times x plus 3 once. Now don't forget, we need to make sure that we don't have any values for our variable that are restricted. So we have each factor set equal to 0. X again is the same factor, so we won't do that. X minus 3 is equal to 0, and x plus 3. Now I'm saying equal to 0, but it really is in fact they cannot have that value. So x cannot have the value 0 when I'm done. Also x cannot have the value positive 3, and x cannot have the value negative 3. So those are my 3 restrictions. Let's come over to the problem and see what we have left. Our first term is 2x squared is equal to 1 times x minus 3 times x plus 3. Well, that came from right here, which is in fact x squared minus 9. So sometimes you can use the problem to help you understand what the answer is. Now this one's a little bit more tricky. It's 1 times x, which is x, and then that's getting multiplied to x, which is x squared. And this 1 times x is also getting multiplied to the 3, which is 3x. Combining like terms and seeing what we have, 2x squared is equal to 2x squared plus 3x minus 9. So we have variables on both sides of the equation. We need to get a 0. We can do that by adding the opposite of both sides. 0 is equal to 3x minus 9. Now we only have one x in the problem. So if we get rid of the furthest thing first by adding 9 to both sides of the equation, we have 3x is equal to 9. Multiplying 1/3 to both sides of the equation, we have x is equal to 3. But recall, 3 is one of our restrictions, and this is the only answer we got. So again, this problem has no solution.